Lesson 7.5, Using the Discriminate. When we work with quadratic equations, we usually have two solutions because of the x squared, but we can have one solution or we can have no real solutions. And it can be helpful to know ahead of time how many solutions to expect before we start. That way we know if we've made a mistake or not. For example, if we're supposed to have two solutions and we only get one. And this is where what's called the discriminant comes in. So what is a discriminant? Well, when we look at our quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac over 2a, the discriminant is this portion of the equation. It's only a small portion of the quadratic formula, b squared minus 4ac, but this can tell us how many answers we should expect to get. If it's positive, we will have exactly two solutions. If it's 0, there will be exactly one solution. And if it's negative, there will be no real solutions, and that is because we cannot take the square root of a negative number. So what does that look like exactly? Well, if we have a positive discriminant, we have a parabola that will cross the x-axis in 2 points, giving us two solutions. If our discriminant equals 0, we will hit the x-axis in 1 point, giving us one solution. And if we have a negative discriminant, we will not hit the x-axis at all, which means we will have no solutions. So in order to determine the number of solutions, we use the discriminant. And again, our discriminant is b squared minus 4ac. We have a, b, and c. We do b squared minus 4ac. That gives us negative 5 squared minus 4 times 3 and 2. So 25 minus 24, our answer is 1. We will have two solutions because we have a positive answer. A, B, and C, there's no number here, so remember that's an invisible 1. So I have b squared, so negative 1 squared, minus 4 times A times C. Oh, I just noticed something. I made a mistake. Hold on one second. I wasn't paying careful enough attention. We have to have our equation set equal to 0 always. So I'm going to move this 2 over and subtract it from both sides. And I'll have 2a squared minus a minus 15 equals 0. Now I can apply the discriminant. b squared is negative 1 squared minus 4 times a times c. And I have 1 plus 120, giving me 121, which is positive, so I will have two solutions. Here I need to set equal to 0, so I'm going to move the 5 over and make it positive. So A, B, and C. So I have b squared minus 4 times A times C. So that gives me 36 minus 160, which gives me a negative 124. Because I have a negative number, I will have no solutions. Or I should say no real solutions. And then setting this one equal to 0, I have 3a squared minus 6a plus 3 is equal to 0, because if I bring these over to the other side, I change their signs. I have b squared minus 4 times a times c. So 36 minus 24, that gives me, sorry, not minus 24, minus 36. That gives me a 0, so I have exactly one solution. Now, in addition to telling us how many solutions we can have, the discriminant can also tell me what type of solutions we'll have. If there are one or two solutions, they'll be either rational or irrational. Rational numbers are integers, fractions, and decimals that end or repeat, and irrational numbers are decimals that never end and never repeat. Non-perfect squares give us irrational numbers. If there are no real solutions, that means we have imaginary numbers, but we don't use those in Algebra 1. Those come up in Algebra 2. So, determining the number and type of solutions. Here I have some examples. I need to set this equal to 0. So I'm going to subtract 2 from both sides. B squared, well, let me rewrite that. B squared minus 4ac. So I have negative 1 squared minus 4 times a times c. So 1 plus 48, 49. This is a perfect square root, so I will have 2 real rational solutions. I need to move my 6x over, so I'll have 9x squared minus 6x minus 11 equals 0. B squared minus 4 times a times c. So 36 plus 396. That gives me 432. Now, just to double check myself, I'm going to take the square root of 432. And it is not a perfect square. And so I will have 2 real irrational solutions. Next equation, I move my x over. I have 10x squared minus x plus 9 equals 0. Negative b squared minus 4 times a times c. So I have 1 minus 360. That gives me negative 359, and so I will have imaginary solutions. And finally, for my last example, 3a squared minus 6a plus 3 is equal to 0. So I have negative 6 squared minus 4 times 3 times 3. So 36 minus 36, which is 0. So I have 1 real rational solution.